Assalamu alaikum, dear students. I am Bashir Ahmad Bhat, lecturer chemistry. Today I will deliver my lecture on colligative properties, and we will discuss in detail one of the colligative property, that is relative lowering of the vapor pressure. It is a topic from the solutions which is in your chemistry chapter 2nd. Now, before discussing colligative properties of the solutions, what is a solution? A solution is a homogeneous mixture of two components. The component which is in larger amount is called the solvent, and the one in smaller quantity is called the solute. So, what are colligative properties? The properties of the solution which now contains solute and the solvent, which depend upon the number of the solute particles but not upon the nature and the composition of the solute, are called colligative properties. These are relative lowering of the vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure. Today, in today's lecture, we will derive the expression for the relative lowering of the vapor pressure. We will also determine how we can calculate the molar mass of the solute by this relative lowering of the vapor pressure, and also a numerical, we will solve the numerical based on this relative lowering of the vapor pressure. So, before discussing this relative lowering of the vapor pressure of the solution, what is vapor pressure of a liquid? You have read in the class 11th. Also, you have read in the earlier topics in the solution how we calculate the vapor pressure. In the Rolle's law, also you know how to calculate the vapor pressure. Let me remind you, if we take a liquid in a container and we have to determine its vapor pressure according to the kinetic theory of the liquids, ये जो liquid molecules होते हैं, they move in different direction with different speed. They possess different kinetic energy. At a particular temperature, some of the liquid molecules, their energy becomes so high that this energy overcomes the force of attraction by the neighboring molecules. Suppose these are the neighboring molecules, and these leave the liquid and come into the space above the liquid. This is called the evaporation. With the passage of the time, more and more energetic molecules leave the liquid and pass into the space above the liquid. This is called, and in the space above the liquid, the vapors also, they are in constant motion. Some of these vapor molecules, they strike the surface of the liquid, and some of them are recaptured by this liquid, and the process is called the condensation. Initially, the rate of evaporation is high, and with the passage of the time, it decreases, and rate of condensation initially is low, it increases with the passage of the time. And a stage reaches when the rate of evaporation becomes equal to the rate of condensation. The pressure exerted at this state by the vapors is called the vapor pressure. So, if we have a liquid alone in a container, when we calculate its vapor pressure, we denote it by A. Suppose we name the component by A, and its vapor pressure will be P naught A. This is the vapor pressure of a liquid of a component in the pure state. Suppose this is another liquid, and another component, we calculate its vapor pressure. Since it is in the pure state and it is vapor pressure at a particular temperature, we denote it by P naught B. And now we are forming the solution. We are mixing the two components and we are forming the solution. What is a solution? Which is a homogeneous mixture of these two components. One is the solvent, another is the solute. And we now calculate the vapor pressure of this solution. Now, according to the Rolle's law, the vapor pressure of the solution, which we denote by Ps, this is the vapor pressure of the solution, it will now be equal to the vapor pressure of the component A, that is the solvent, and plus vapor pressure of the component B, which we are taking in smaller quantity, that is the solute. So remember, we are here mentioning B as solute and A as the solvent. And if we have now a solution which contains non-volatile solute, what do you mean by non-volatile solute? The substance which does not evaporate readily at the existing condition is called a non-volatile solute. वो non-volatile solute जो होते हैं उनका वेपर प्रेशर जो होता है वो बहुत ही कम होता है. नेचुरली उनका बॉइलिंग पॉइंट जो होगा वो बहुत ही हाई होता है. Now we are taking a solution which contains the non-volatile solute. That means the Pb, which is the vapor pressure of the component B of the solute, it will be now 0 because we are taking the non-volatile solute. So the vapor pressure of the solution will be only due to the vapor pressure of the component A in the solution. And again, as you have read in the Rolle's law, the PA, the vapor pressure of the solvent in the solution, is equal to XA P naught A. That is, what is XA? XA is the mole fraction of the component A. And what is P naught A? It is the vapor pressure of the component A in the pure state. And what is PA? PA is the vapor pressure of the solvent in the solution. Again, we know that if we have a solution of the solute and the solvent. Suppose XB is the mole fraction of the solute and XA is the mole fraction of the solvent. Sum of the mole fractions in a solution is always equal to 1. And from this, XB plus XA is equal to 1. We can write XA is equal to 1 minus XB. What is XA? This is the mole fraction of the solvent. And what is 1 minus XB? This is XB is the mole fraction of the solute, and we will put it in this equation first. Now this equation will become PA is equal to XA के बदले हम लिखेंगे 1 minus XB into P naught A, and PA divided by P naught A is equal to 1 minus XB. और ये हम इधर ले लेंगे, XB is equal to 1 रहा इधर 1 minus PA divided by P naught A. Cross multiplication, P naught A minus PA divided by P naught A, और here instead of PA, क्योंकि PA किसके बराबर है? This is the vapor pressure of the solution. We can also write this as, instead of PA, we can write PS. It is PS. PS is equal to PA. लेकिन PS डिनोट करता है वेपर प्रेशर ऑफ द सॉल्यूशन एंड PA इज द वेपर प्रेशर ऑफ द सॉल्वेंट. द वेपर प्रेशर ऑफ द सॉल्यूशन is equal to the vapor pressure of the solvent because we are taking the non-volatile solute, or XB is equal to PS. This is PS again, or we can write P naught A minus PS divided by P naught A is equal to XB. What is P naught A? This is the vapor pressure of the solvent in the pure state. This is minus the vapor pressure of the solution. This is called the lowering of the vapor pressure of the solvent, and if we divide it by the vapor pressure of the pure solvent, it becomes equal to a relative lowering of the vapor pressure. Thus, relative lowering vapor pressure is equal to mole fraction of solute. This is the expression for the relative lowering of the vapor pressure. Now, an important aspect of this relative lowering of the vapor pressure or the colligative properties is that we determine the molar mass of the solute by these properties. So, determination of molar mass of solute by this relative lowering of the vapor pressure. Again, we can write that P naught A minus PS is equal to P naught A is equal to XB. Now we will write the mole fraction in terms of the number of the moles. XB is also equal to NB divided by NA plus NB. The mole fraction of the solute is equal to the number of moles of the solute divided by total number of the moles. Similarly, if we have XA, we can write XA is equal to NA divided by NA plus NB. Mole fraction of the solvent is the number of the moles of the solvent divided by total number of the moles in the solution. Now, instead of XB, we will now write NB whole divided by NA plus NB. Now, NA, it is also equal to WB divided by MB whole divided by WB by MB प्लस यहाँ से A लिखा मैंने WB by MB. Now what is this WB by MB? WB mass of solute. What is WA? Mass of solvent. What is MB? This is molar mass of solute. And what is MA? This is molar mass of solvent. Since we are applying the Rolle's law, and Rolle's law is applicable only to very dilute solutions. Now what is a dilute solution? In a dilute solution, the number of the solute particles are negligible or very small as compared to the number of the particles of the solvent. So we can write this like this. And B, the number of moles of the solute for a very dilute solution is very small as compared to Na. Hence, these are ignored as compared to the number of moles of the A, or in other words, we can write Na plus Nb is approximately equal to Na, the number of moles of the solvent, or Wb बटा Mb इसके बदले WA बटा MA प्लस WB बटा MB is approximately equal to WA बटा MA. Here I will explain again. If WB grams of the solute are having the molar mass Mb or dissolved in the WA grams of the solvent having molar mass Ma, then we can write this equation becomes WB bata Mb whole divided by WA bata Ma plus WB bata Mb. Since the solution is dilute, the number of moles of the solute are very small as compared to the number of moles of the solvent. So these are neglected when we add the two. So the addition becomes approximately equal to the number of moles of the solvent, or this Na, the number of moles of the solvent, which is equal to the mass of the solvent divided by the molar mass of the solvent. The number of moles of the solute, which is equal to the mass of the solute divided by molar mass of the solute, will be equal to WA bata MA. Now this equation we will substitute here this and this equation, we will write it equation second, and it will become P naught A minus PS whole divided by P naught A is equal to XB is equal to NB bata NA plus NB is equal to WB बटा MB whole divide by इन दो के बदले अब हमने this is approximately equal to WA बटा MA which is equal to WB बटा MB into इसका ये डिनोमिनेटर में है, इसका न्यूमरेटर जो है वो डिनोमिनेटर बनेगा और डिनोमिनेटर जो है वो न्यूमरेटर बनेगा MA divided by WA, or we can write P naught A minus PS divided by P naught A is equal to WB divided by MB and MA divided by WA. Ma, this is the molar mass of the solute, non-volatile solute. Knowing the values for the vapor pressure of the pure solvent, the vapor pressure of the solution, the mass of the solute, mass of the solvent, molar mass of the solvent, we can calculate the molar mass of the non-volatile solute by applying this equation. Now we have a numerical, and based on this calculation, how this relative lowering of the vapor pressure helps in determining the molar mass of the non-volatile solute. Let's take the numerical, and I will turn the board. We have the numerical like this. The vapor pressure of the benzene at a certain temperature is 0.850 bar. A non-volatile, non-electrolyte solid weighing 0.5 grams when added to 39 grams of the benzene, molar mass 78 grams per mole, vapor pressure of the solution then is 0.845 bar. What is the molar mass of the solid substance? Now I will explain this like this. We have benzene and it is a solvent, and in the benzene we are dissolving the non-volatile solute. How much? 0.5 grams. So the non-volatile solute, the mass of this non-volatile solute is 0.5 grams, and benzene is the solvent. The mass of the solvent is equal to, it is 39 grams. That means the WA of the benzene, the mass of the benzene is 39 grams. And when we add this non-volatile solute, the vapor pressure of the solution by the addition of this non-volatile solute in the benzene decreases, and it becomes equal to, the vapor pressure decreases from 0.850 bar to 0.845 bar. That means the vapor pressure of the benzene is 0.850 and the vapor pressure of the solution is 0.845 bar. That means the vapor pressure decreases, vapor pressure of the benzene decreases from 0.850 to 0.845 by the addition of the non-volatile solute. Now we will apply the formula, relative lowering of the vapor pressure, that is P naught A minus PS divided by P naught A is equal to WB बटा MB जो अभी हमने डिराइव की इंटू MA बटा WA. What is P naught A? P naught A is the vapor pressure of the benzene, that is 0.850 bar divided by 0.845 bar is equal to mass of the solute, that is 0.5 gram divided by MB. We have to calculate this MB into MA, mass of the molar mass of the solvent, that is 78 grams per mole, divided by mass of the solvent, that is 39 grams. ग्राम्स कैंसिल, बार बार हम कैंसिल करेंगे. इसको डेसिमल भी खत्म कर सकते हैं. सॉरी, दिस इज 85 माइनस 0.845 बार. बार कैंसिल. इसको जब सब्ट्रैक्ट करेंगे, इसको भी डेसिमल के दाईं तरफ 3 डिजिट्स हैं, इट विल बिकम 0.005005 divided by 0.845. बार now cancel, is equal to 0.5 divided by MB into, ये इसका ग्राम और ग्राम 39 2s are 78. This is 2 gram per mole divided by 1. इसके दाईं तरफ डेसिमल के दाईं तरफ 3 डिजिट्स है और इसके दाईं तरफ 3 डिजिट्स है. वी कैन आल्सो राइट इट लाइक दिस. इट बिकम्स 5 divided by 1000 whole divided by 845 whole divided by 1000 cancel. We can write 845 is equal to 5 divided by 10, डेसिमल खत्म करेंगे, into MB into 2 grams per mole. MB हम यहाँ ले लेंगे और ये दाईं तरफ ट्रांसफर करेंगे. तो MB ये डिनोमिनेटर में है, ये न्यूमरेटर में आएगा. MB इज इक्वल 5 डिवाइड बाई 10. ये न्यूमरेटर में है, ये यहाँ पर आके डिनोमिनेटर में आएगा, और ये डिनोमिनेटर में है, क्रॉस मल्टीप्लिकेशन में ये नॉन न्यूमरेटर में आएगा. This is again we have written, it is P naught A is 850. 850 divided by 5 into 2 into grams per mole. 5 cancel, 2 ones are, 2 fives are. So MB is equal to 850 divided by 5, that is equal to 170 grams per mole. So in this way we have calculated the molar mass of the non-volatile solute, which is equal to 170 grams per mole by this relative lowering of the vapor pressure. Now, dear students, if you have any doubt and any question, you can send those questions to my WhatsApp number, that is 99064366617, and I will try to solve your problems and give you the answer. So because there is limited time, so we have to conclude it very quickly. Thanks.